don't think I'm scheduled to start until 3:10, but we're going to keep it rolling, right? Okay. Well, I didn't do any fancy slides for introductions. My name is Neil Desrosiers. I'm with MTConnect Corporation. If any of you attended the user group, I gave a little bit of bio there, but my background is I'm actually a machinist by trade. I got Microsoft certified, and this kind of led me into the role of the MTConnect's MTConnect representative. Part of my job, in addition to writing adapters and helping customers, is troubleshooting implementations at the customer's facilities and in our shop, our factory as well. So they asked me to speak about the top 10 troubleshooting issues that we've dealt with. And some of these that I have in here, I think I actually have about 12 or 13. Some of them are very bring me personal pain. So this is kind of a good way to vent and tell you guys, avoid these things. They're gotchas, and some of these come up daily, and they're very easy to avoid. And some of them start getting a little more complex. But without any further ado, so probably the biggest thing that I run into is the wrong adapter being purchased for a machine tool. Depending on the age of the machine tool, depending on the model or the control type, the adapter that has to get purchased for that is unique. We have Windows 95, we have Windows 2000, so it might be something that's operating system specific. There's also things such as the proprietary API that we have to interface with on the controller. So it's very specific. We actually have a lookup table, and we tell the customer, if you fill out this factory inventory and you give us everything that's on this list that we're asking for, including the model of the machine, version of software and such, I will tell you what adapter you need to have. And it really avoids a lot of problems. We do publish that chart, and people can use it to look up which adapter they need. But a lot of times it gets done blindly, and it's probably it's a big source for some problems. So make sure that you ask the builder of the device, the OEM, get them to help you with the selection of the adapter, and make sure you're purchasing the right thing. Some of the controllers, including things such as the black boxes that you get, are adapters. Some of the controllers, we can only install the adapter. We don't install the agent. It's a very old machine. It's a very old control. The resources on that control are limited, so we only put the adapter on there. We want to give you information out of there. So rather than saying we don't support that machine, we say, you know what, we're going to put some software on there. We're going to make it an MTConnect adapter. Let it speak MTConnect, or let it get data out of there. But it will require the end user to have an agent somewhere running on their network. So your device is not compliant unless it has an MTConnect agent representing it somewhere on your network. So when you buy an adapter, if it doesn't tell you that, hey, it has an MTConnect agent in there as well, you might want to ask the question. I know we specifically send on the USB jump drive out to be installed, we send a folder out there. If it needs an agent, it'll say standalone agent, and it'll already be pre-configured for your machine model, and all you have to do is copy that folder and install it and run it, and you should be fine. So make sure that you do know whether you have an agent or not, because your client application, whatever software you purchase, they're going to go out there, they're going to say, okay, I need the address, the IP address, and the port for where these agents are running. And the assumption is always that it's at the machine tool, because every modern machine tool, we run the adapter and agent right there on the machine. So they'll assume that it's there, and they'll go out and they'll hit port 5000 with a browser, and they're expecting to get XML data, MTConnect data back, and it doesn't happen. And they think something's wrong. The adapter's there, it's running, it just doesn't have an agent. This one here is interesting on some of the older equipments. The MTConnect agent and actually the adapters as well have the capability of producing log files. On the older machines, the hard drives are pretty small, and they're usually filled up with the users or the operating system and the interface for the machine tool. So there's limited hard drive space that's left. You install an adapter in there or an agent, and the log file in the configuration file for the agent, if you have the logging level set to debug, that's like I'm testing it. And I want you to output any type of information that you could possibly give me about what's happening with that agent, which means it's giving as much information to that user that's installing it as possible. The problem is if you forget to set it to something like fatal or just information only, that thing continues to grow, and that file can continually grow. There is a setting in there that allows you to set a limitation to file on the new agents and such, but that's not usually set by default. So it can get to a point where you literally fill up your hard drive with this one big file. So you have to be careful about making sure you set that. And I'll have people that call me up and say, hey, the machine's starting to get slow, something's going wrong. And I say, go in there and look at this folder. And they say, oh my God, I got this file in there. It's huge. Change the setting in the configuration file. Something that's always a gotcha, the Windows firewall.
I'm sorry.
Yes.
Just a quick question about this slide that you just showed.
Sure.
You said sending tags that the device file does not support or map. Is there a way to find out what is supported before you map it?
What happens is the agent is outputting adapter tags, and we document that, and we can provide that. But what you can also do at the configuration file at the agent level is you can actually block data from being mapped. So let's say, here's an example. I have live agents online that you as end users or software developers can use to test your software. But I also don't want to give you all of our positional data of our machines as they're running. I mean, technically, you could reverse engineer our parts. Rather than try and rewrite an adapter and say, don't output access data, what I do is I go in there and I just remove the access data out of the XML, and it doesn't get mapped. But the agent says, I didn't find that data tag, and it sticks it in the error log file. And that just can keep building. So in some cases like that, it would just continually fill up that file. But you can certainly find out what's mapped. And when you first install it, we test them before they go out. We know what data's coming out. We know what data should be in the text file.
So what I mean is, so like say you're setting up a new machine, do you have to go to the machine manufacturer? Is there a command or something you can do from the agent just to find out before, to know what to put in that map file before you have any idea?
It'll be done for you, but you could. You could use a telnet, like a telnet or a putty or something like that, something that's a telnet client. You could hit the adapter directly, and you could see what the output is and find out what those tags are, sure.
Okay, thanks.
Yeah, but usually pretty much everybody gives you the file. Let's say you want to create you have an adapter and you want to create a standalone agent somewhere. You could call us up and say, hey, do you have a device file for this particular machine model, and we'll send it to you. Yeah. So Windows Firewall. I mean, by default, Windows firewalls are locked down. Your IT department will turn them on all the time by policy. And then even though you may have turned it off, it might turn it back on. One of the things I've done with our most recent installers is that I have a script that I run that creates the exceptions for the adapter and agent to make sure that you can get to them and that they they function properly around the firewall. Because we could test things locally on the machine tool. I can open up a browser, I can test the agent, I can open up a telnet session on the machine tool, and I test the adapter. I say everything's running, I can see the data, what's happening. They can ping the machine from the server, and they can say, I can see the machine on the network, but when I try and get to the agent, it's giving me an error. It's just because the firewall's turned on. So that's one that bites you every once in a while. In the case that you heard Nate speak of earlier, how they implemented their agents. In this case, the way we do it at Mazak is we have a server, a virtualized server, and we decided to, for manageability purposes, is we installed all of these agents onto the server. By default, the agent uses port 5000. I can't have every single agent that's up there. I have 54 machines. I can't have every agent using port 5000. Okay, there's only one port 5000, only one application can use it at a time. So every agent has to be configured with its own numeric port number. You have to make sure you increment it or use some sort of different number. We like to increment them systematically. So it's interesting from the client side or an application side or data collection side, that software, that company that you use as a client application has to know what those port numbers are. We document it as we install it. And when we installed our client application, I gave them a sheet of paper and said, here's where all our agents are. And here's all the port numbers for them. Here's the machine names. And they just went in there and just typed all the data in, and they were getting data. If they set all of their data collections to that same server, and all of them went to port 5000, I'd have 54 machines that looked identical, because they'd all be getting the data from the same location. So it's important to make sure that your port numbers are set correctly. Another thing that happens is somebody gets creative and they say, okay, I'm going to do this. I have a machine. It might have an adapter and an agent on there already. But they say, I want to do a standalone agent. I'm going to do like Mazak does or Task Force Tips. I'm going to put these agents on a server. And they start doing these standalone agents. Well, that's fine. They call up Mazak and they say, hey, here's all my machine lists. I need device files. I give them all the device files. The name in the device file is very important. There's a name attribute at the top of the file. It needs to match what's in the configuration file. You need to say, this is where it is. It's important when you do a configuration like Nate had, where he has all of the device files in one agent, that name has to be different on each one of those. And you query the data from that machine. If you say, OK, Mr. Agent, on port 5000, you represent 54 machines. I want machine 48, and it's called this. I have to send it the name to get the data for that machine. So if the name is wrong, the agent's going to generate an error. That'll bite you every time. And you say, hey, the agent's not running. It's giving me errors. What's going on? First thing I have people do is say, go in there and look at that device equals what? And that name, in this case it was Mazak, it has to be that. It might be VCN something. It might be your asset number that you want to put in there, you know, a machine or M1234. That has to match, the configuration file has to match what's in the device file. So in the case of networking issues.
In the previous issue, is there a
Yep.
precedence, one you would change over the other? If they're
No.
not equal, which one would you change?
Doesn't matter. It's preference, what you want. Yep. Nothing but preference. I know somebody that implemented their asset numbers on their machines. A lot of customers put like the M numbers on the side of the machines. They spray paint them. They say it's M1234, 1236, 1238, whatever. They put that in there and they represent their numbers. Some of them are more cryptic. They put this real long cryptic, and they look at it and they know what building it's in, just by looking at the name, but it's entirely up to the end user. We have default names that we put in them. So in the case of networking, you have to make sure that you're using the right IP address for the adapter. I have machines or black boxes. I have 20 machines in our factory that are legacy machines. They don't have any controller on them per se. Some of them are manual machines, and they're running black box adapters. So they're sitting there running, and they have a port 7878, which is a default port for an adapter. And the agents connect to that all the time on that port. Or they go out there and have to connect to get data. What if the IP address is wrong? I have that configuration file for the agent that says, here's the device name, here's the file, here's the logging error level that I want to do so I don't put too much data in my file. Here's the adapters. Where am I getting my information from? Here's the IP address and the port number for where the adapter is located on the network. If that adapter is wrong, you're going to get an error. The agent will never collect and get data. If it's wrong and it's set to another adapter on the network, the wrong one, you're thinking you're getting information from this machine over here, and really you're getting information from a different one. So newer equipment, we install the adapter in the agent. It's all pre-configured with local host, and it grabs on port 7878, collects the data from the adapter. Everything's working great until somebody says, I want to do something creative, or you have to put an agent somewhere. You've got to make sure you have the IP address and the agent, the location of the adapter and the port set correctly in the agent configuration file.
Are host names supported in that, or does it have to be
That is entirely up to your implementation on your network. If your company is using DHCP and is providing IP addresses to all those machines, that IP address could change, right? It will work that way, but that's entirely an end user issue. The problem is if you hard code that in there and the machine goes down for a period longer than the reservation on that address, and the machine gets a new IP address, you're going to run into a problem, and all your machines are going to get mixed up, right?
So you could put a host name?
Yes. Yep. Yeah, we do on some of our machines. Actually, in our factory, what we did was we went through and used DHCP to get the value. Then we called our IT department and said, reserve that. Don't let it ever change. Always give me the same one on that MAC address. So, something interesting that happened, and this has been at least a couple years ago. We use Telnet, and we connect to an adapter on port 7878, and we get information back. We see what we call the shutter code. We see this key value name pair, and that's not part of the MTConnect standard, but it's the standard language that the adapter spits out. So that's really cool. And then we open up a browser and we test the agent, right? Because it's HTTP, it's a web service, and we get back XML data. Someone one day said, hey, I don't need to use a Telnet because my browser, whatever browser it was, I accidentally put port 7878 in there, which was the adapter, and I saw the data come out. That shutter data came out. It wasn't HTTP, it wasn't XML, but I saw the adapter. So I can use one tool to test both devices. I'm like, that's really cool, great. Yes, I tried it, hey, it works. What was happening was everybody was telling people, hey, you can use a browser. And they try it, and it works great. We start having problems. So adapter's not running. Things have shut down. We don't know why. Restart the machine. Everything works fine. And consistently something keeps happening. The adapters kept shutting down. Went in there, we started troubleshooting. I duplicated. I said, why did that thing shut down? I hit it with a browser and the adapter shut off. What happened? There's a set of commands that can go back and forth between the agent and the adapter. One of them is the adapter is allowed to tell the agent to say, hey, I want to update the UUID. I want to update the manufacturer name. I can say, hey, this is a Mazak adapter. This is such and such. And it says, OK, I'll change the file to that. But when you hit the adapter with a command, they start with an asterisk. And it looks it up in a list. And if it doesn't find it, what happens? The code that we had, and it was the code that came actually from, we downloaded from GitHub, from the Institute, it was the original code, had a fallout. And it literally said, if it's not this command, if it's not this command, not this command, then shut down. Okay, so what was happening was somebody hits it with a browser, and the browser, the header of a HTTP GET has some asterisks in there. And it was forcing that adapter to shut down when they were testing it with a browser. So there's a lot of adapters out there, is my point. Anybody who generated and made adapters with that original code, there's tons of adapters out there that will shut down if you hit them with a browser. And we keep running into them every once in a while, and we update ours. But we know there's tons of them out there. So it's something to keep in mind. This one here is one that's real painful to me. There are traditional ways of collecting data from PLCs. And they say, OK, they go out there and they collect data and they're polling it. And one of the things they don't want to do is they don't want to miss an event. So something goes high, a bit goes high, a signal goes high, and a signal goes low. And if they haven't hit that or polled that PLC in that time that it was high, they might miss it. And so they say, I want to poll extremely fast. I want to hit that thing extremely fast so that I don't miss any data. So now MTConnect comes along, and they say, oh, I can get the data. They go out there and they use a current command, and they get the data, and they say, well, I don't want to miss anything, so I'm going to continue getting data from this, so I'm going to poll it, and they keep going current, 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 current. And although that's an acceptable way to get data, it's not an acceptable way to get data repeatedly like that. You should not use current to get consistent data. There's a way to do it with a sample command. And the way sample works is you're accessing what's called the buffer that's on there. But with sample, not only can I access the buffer, I can also force it to stream the data to me. So what I do is I go out there and I say, I want to probe the agent, and I find out what all of the data tags that are available. It sends me the device file back. I document what's known as the instance ID of the agent. Say, make sure if this thing reboots, I'm going to know if it reboots. Then I would do a current command and get all the data that's in that system, and I know all the last known tags, what the values are for those tags. And then the third thing I do is I go back and I say sample. And in that sample command, I say from the last tag that I got, I put a from parameter on there. From the last tag that I got, I want you to send me anything that changes. And I put an interval in there, and I say I want you to send it to me in an interval of 2 seconds, let's say. And I just sit there and capture the data. My client application captures the data. I don't have to keep polling. Anything that happens there that data changes, anything that would go into the buffer is going to be sent to me as well. This is the proper way to do it. If you go and you're constantly doing current, 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 it's fine for a simple dashboard that maybe you hit a current every 4 seconds or 3 seconds on an agent. But if you go out there and you press current and you're hitting that thing less than 1 second, especially on older pieces of equipment that have low CPUs and low resources, you're going to run into a problem. You're basically doing a denial of service attack. You're going to shut down the agent. It's just going to overwhelm the CPU and the resources on the controller. So I always tell customers, if they have a problem like this, I say, hey, let's put the agent up on a server. And it convinces them, and next thing you know, everything's running fine, the machine's running fine. There's no issues at the machine. The issue's now at the server, and they're saying, wow, the CPU on the server is just spiking and everything. It's because these client applications or data collectors are just polling these agents too much. So you want to make sure if you don't know how to stream data and you have a client application and you're collecting data, then you try and learn how to do it. The documentation is there to know how to do it. This one here doesn't happen too frequently, but it does happen. And the place where I see this happening is software companies that say, OK, we're going to start doing MTConnect because somebody asked us to. They queried a machine with a browser, and they got data back, and they look at it and say, oh, that's not all that difficult. So they start querying information from the machine. And they never really learned all the intricacies of how to query an agent properly. So when you say sample, I go out there and I hit sample. I'm accessing the buffer of the agent. And that agent can be huge. That could be one day's worth of data. It could be 2 days' worth of data, depending on how many tags are being generated. It could be a lot of data. So when you hit sample, by default, you're going to get back 100 pieces of data by default. It won't let you go over 100 by default. What people think is that 100 pieces of data are the last 100 pieces of data that went to the buffer. It's not. It's the first pieces of data. It's the stuff that's a day old or 2 days old. So I've had client software vendors sitting at a customer with me on the phone with the customer, and the customer's upset. And I said, change the machine mode. They change the machine mode, and they say nothing happens. Why? They're saying sample, and they're going out and getting that a day's worth of old data and the last known state of the machine. And it's old data. It's a day old, so nothing's changing. What you need to do is if you look over here on the left, you see I got a sample. That's the same thing as saying if the oldest piece of data was index number 1, there's index numbers in there, or sequence numbers. If it, for example, was number 1, it's the same thing as saying from number 1 and give me a count of 100. So you're getting all the old data in the buffer. If you want to get the most recent data, assuming that there's 1,000 pieces of data in there, I would say I want to get it from 900 at a count of 100. Give me the last 100 pieces of data. So the issue was they just weren't using the buffer properly. They didn't know how to use the semantics of that buffer. They weren't sure how it worked, and they were just querying it, and it was wrong. And I get this infrequently, but it is an issue, and it's causing problems because what's happening is the end user gets this feeling that MTConnect is not working properly, where in fact it's somebody that's using it or trying to use it and is not using it properly. So sampling the buffer of the agent is the proper way to do it. You just got to make sure you do it right. And a lot of these slides that you see here are actually from our boot camp that we have every couple months. So these are the type of things that we cover, and we make sure that the people are doing it correctly. So something that came up really recently, and it has something to do with sampling, is we're getting more and more into sensors. And we're talking about high frequency versus low frequency sampling. I talked about using a polling of 2 to 4 seconds if you're doing dashboards. If I have a dashboard out in the factory, I don't need to watch that thing every millisecond or every 10 milliseconds. I look up, as long as when I change something, I see the status of the machine changes up there within a couple seconds, that's plenty fast. It's just a dashboard showing you live data. But if you're looking at high-frequency data, if you don't want to miss anything, if you're doing a database collection, you're going out there, a historian, you're collecting the data, you're putting it in a database, you want to make sure that you don't miss anything. And this is where some of the people do it wrong, is they go out there and they start hitting current on their agent to make sure they don't miss anything, where in fact, all they have to do is do a sample with a from and an interval, and they sit back and capture the data, and then they put it in a database. To give you an idea of how powerful this is, I don't have the actual values of the benchmark I did, but I was testing a machine, and I was polling it really fast. And it was just a handful of machines, probably about 20 machines. And I was polling it really fast, and I was literally bogging down. I mean, I could see the bandwidth. I could see it was getting heavy. In contrast, I wrote a data collector that would collect every single piece of information out of an agent. And anytime it changed, I would get the data because I was streaming it, and I was trying to learn how to do streaming properly. I was at home with my cell phone, had my laptop with a Wi-Fi hotspot, doing VPN over a 4G AT&T connection to Mazak. I had 54 machines. I doubled that number. I basically copied all those in my database. I made 108 machines. So I was collecting 100% of the data from 108 machines over a VPN 4G connection. It was less than 0.5% on my CPU. It was only about 10 meg, and it was mostly because of all the processing, the threading that I had in there. And the bandwidth is insignificant. And the reason why is that it's only sending you information when something changes. And I was amazed at the performance. And so I've become a real proponent of doing streaming and making sure it gets done correctly, because you can stream that data. And somebody used to tell me that all the time. Will used to yell at me all the time. He says, you got to do streaming. You got to do streaming. I'm doing streaming now, and I'm a believer. It works fantastic. If the client apps that are out there now aren't streaming data, convince them to do it. Because I run into problems where I actually have to pull up a packet sniffing software at the customer. I'll bring up what's known as Wireshark, and I'll watch their data hitting the machine, and I'll say, you're hitting this thing every 100 milliseconds. You need to stop doing that. You're basically bogging down the web service. So it's important that it gets done right. But high-frequency data, when we start getting into doing sensors and you want to have interfaces between machine tools and robots, or machine tools and bar feeders, or eventually machine to machine, you want to make sure that this communication is being done efficiently. It's something that needs to get educated on, and everybody needs to know how to do it.
What did that say in that sample line? What was that after the ampersand?
Oh, there's a from, and there's a number there which is just a fictitious sequence number in the buffer. So when I do a probe, I do a current after that, and I say, give me the last known value that's in the buffer. In other words, the last piece of data that went in the buffer. And that data flows through the buffer. That sequence number is the last one that I had. I say, from that number plus 1, which would be that fictitious number, and I said, at an interval of 2,000 milliseconds, send me anything I missed.
That's the interval.
Yeah. Right. And an interesting thing I learned this week was that if you had interfaces or you have extremely high frequency data, you can set that interval to 0 on the new 1.3 agents. And what it'll do is it'll set that agent thread of execution to a high priority. And it'll make sure that the performance is there, which is really powerful.
Like a Windows high priority?
Yeah.
That's nice.
Yeah.
That's scary.
Yeah. Well, I haven't tried it. I haven't had a need to do it.
I've done
So.
some prioritization there, and we got some of our products, and we set it to a we set one third to a higher level. Everything else falls down.
Sure. So for example, if you're doing this on a server, not so much of an issue, right? It's on a server. It's designed to do this computing and such. If the agent's on a CNC, you might want to be careful about doing that if you're doing some heavy stuff like that. You might want to offload it to a server or a PC or something. But it is possible to do. So that was real interesting to learn. So I learned something this week.
So if nothing changed in the interval, will it still answer back and say nothing changed?
It'll send you back at a certain interval. Like depending on what you send, you can actually set that to like say I send it to 10 seconds. After 20 seconds or so, it sends you a dummy. It sends you like a heartbeat. It sends you an empty XML file. But it was so small that as you're watching that data come in, I was actually echoing it in my development tool, and I'm just watching. So it's boop, 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 boop from different machines. This data coming in, it's just trickling in, and it was like, this is so lightweight, and we're just taking it, parsing it, and sticking it in a database. So it's pretty streamlined. Any questions?
So unit of interval, is it seconds?
Yeah, milliseconds.
Milliseconds.
Yeah.
So you demo code on the website for streaming?
I don't. You can stream from the website. In other words, a client application will send that command to. Oh, you mean my code?
Well, anybody's code.
I do have some simple sample code that I did. Will, is there one?
Yeah, there's actually, look on the MTConnect website, the GitHub.
A GitHub, yeah. If you go to github.com and you type in MTConnect, you search for MTConnect, there's a bunch of open source projects there. One of them is, what was it called? The streaming? Streamer.
There's one written in, let's see, we have Ruby, Python, C#, NetC. Okay.
Yeah.
So maybe one of those will get you.
Yes?
Default behavior with interval, if I just have a sample question mark interval equals number of milliseconds to initially stream the entire buffer, and then only do the differences from that point on?
No. That's interesting. Is if I connect to something and I do a probe for a current, I get the last information in the buffer and I use that value to say from. If you don't do from, it will start from the beginning of the buffer. I do it in class all the time to show them. I said, if you don't put anything there and you do a sample, I just watch the data just scrolling on the stream, and you sit there and you wait and you wait and you wait, and basically you're getting maybe a day's worth of data, and it just keeps going. Then finally it stops, and then it starts trickling, and you just start seeing the changes come in. So yeah, it's unless you want to get that bulk data sent to you, and you don't need a day's worth of information, then that's fine. Okay. Great. Thank you very much for your time.